In this section, we're going to look at general factoring strategies. So we've talked a lot about technique in factoring, given different scenarios with trinomials and binomials and special polynomials. And here in this section, we're just going to loop it all together in one big problem set. Can you factor something if you just look at it? Can you know what to do? So here's sort of a checklist of things that you need to be thinking about when you're trying to figure out how to factor something. So the first thing, always look for a greatest common factor. Is there something that's common to all of the terms that you can factor out before thinking about anything else? Because usually that can make things a little bit easier. Secondly, if there's a binomial there, so just an expression with two terms, is it the difference of squares? Because if it's the difference of squares, of course, a squared minus b squared will factor into the quantity a plus b times the quantity a minus b. So recognizing that can be helpful. Most of what we worked with were trinomials, though, right? If there's a trinomial, ask the following questions in this order. It'll help you out. So first of all, is it a perfect square trinomial? So with the a squared plus 2ab plus b squared. So look at the first term and the last term in the trinomial. If they're both perfect squares, kind of check out the middle term too. Is it a perfect square trinomial? Because using those special forms, that the fact that a squared plus 2ab plus b squared equals the quantity a plus b quantity squared, or minus, if you have a minus in the middle, that can be really, really, really useful and save you a lot of time in trying to hash out the AC method and things if you just notice that, okay? So most of our trinomials are not perfect square trinomials. So what happens then? Okay, so if the leading coefficient is 1, if a equals 1, find factors of c that add to b, right? And use those as your factoring numbers in the two binomials that you need to find. Okay, if the leading coefficient is something that's not 1, use the AC method to factor out. If a and c are both prime, sometimes guessing and checking is a little bit faster than the AC method, but the AC method always works, you know, if you have a leading coefficient that's something other than 1 and you don't have a perfect square trinomial. So, of course, with the AC method, we're multiplying a and c together, and we're finding two numbers that multiply to give us AC and add to give us b, right? And then rewriting the middle term with those two numbers, and then do the factor by grouping, okay? Now, if you don't have a binomial or a trinomial, but you have something with 4 terms, you can try the factor by grouping method. Doesn't always work, but that's sort of where you want to go with it. Okay, so this just puts it kind of all on the page, the things that we need to be looking out for and doing. Okay, so let's give it a try. Let's do some examples. All right, factor the following expressions completely. So the first one we've got is x squared minus 11x plus 18. So x squared is a perfect square, but 18 is not, right? And there's no GCF to pull out of this. So with this trinomial, since it's not a perfect square trinomial, its leading coefficient is 1, right? So in this case, all we have to do to factor this into the product of two binomials, we're going to have x and x, right, as the first term in each binomial. And then we have to find factors of positive 18 that add to negative 11, okay? And the first two that come to mind are 2 and 9, right? And if both of them are negative, negative 2 and negative 9, that will give us negative 11, right? So negative 2 times negative 9 is positive 18, right? But negative 2 minus 9 is negative 11, right? So we're going to have minus 2 minus 9, right? So fully factored, we'll have the quantity x minus 2 times the quantity x minus 9, right? Now, the signs of the two, the negative 2 and negative 9, again, because we have positive 18 as our last term, they either both have to be positive or both have to be negative. The middle term is negative, so that means they both have to be negative. Okay, so now to check this, x minus 2 times x minus 9, if we FOIL that back through, do we get what we started with? So x times x is x squared. For our outer, x times negative 9 is negative 9x. Negative 2 times x is minus 2x. And negative 2 times negative 9 is positive 18. In the middle, negative x minus 2x is minus 11x, right? So we end up with x squared minus 11x plus 18, which is the original statement that we started with. So now this next one, 9x squared minus 18x plus 5. It's another trinomial. Does it have a GCF we could pull out? 9 is a factor of 18, but 5 is not a factor of 9 or 18, and 5 is prime. So we don't have anything we can pull out of this. 9 is a perfect square, but 5 isn't, right? So it's not a perfect square trinomial. And the leading coefficient is not 1, right? So we're forced to use the AC method there. You can guess and check it if you want it, but we're going to get some practice using the AC method. So 9 times 5 is 45. And we want factors of 45 that add to negative 18. Okay, so 45 isn't divisible by 2, but it is divisible by 3, right? 3 times 15 is 45. Okay, and I also notice we need it to sum to negative 18, right? Because we need two numbers that multiply to give us positive 45, but add to give us a negative number. They both have to be negative, right? Negative 3 and negative 15. So I'm going to use those two numbers to rewrite the middle term. I'm going to have 9x squared minus 3x minus 15x plus 5. Okay. Now, with these four terms, I'm going to do factor by grouping. Now, because of that negative in the middle, the negative 15, when I group this last set, I have to change this sign to a negative number, right? I have to change the sign on that last term to be negative, right? So when I distribute it through that negative through, I get negative 15x plus 5. Okay, so now do a little more factoring here. In the first grouping, the 9x squared minus 3x, what can I pull out of there? Well, 3 for sure, and an x, right? So 3x times 3x is 9x squared, and 3x times negative 1 is negative 3x, right? So we have 3x times 3x minus 1. Now in the second grouping, I can pull out 5, right? That's what's common to 5 and 15. Okay, so 5 times 3x gives 15x, and 5 times 1 is 5, right? So we have 3x minus 1 there. Now, 3x minus 1 is common to both of the terms, right? So I can pull out 3x minus 1. And the leftover will be 3x minus 5. Fully factored, we have the quantity 3x minus 1 times the quantity 3x minus 5. Checking this, I'm going to FOIL 3x minus 1 times 3x minus 5. See if we get the original expression. 3x times 3x is 9x squared. 3x times negative 5 is minus 15x. Negative 1 times 3x is minus 3x, and negative 1 times negative 5 is positive 5. So 9x squared minus negative 15 minus 3x is minus 18x plus 5. Okay, now 9x squared minus 18x plus 5, is that what we originally started with? Yes, it is. Very good. Okay, now looking at this last example, negative 4y cubed plus 36y. Okay, so it's a binomial and it's got a lot of stuff going on. I notice a greatest common factor I can pull out, right? The negative out front is problematic, so you want to always pull the negative out if you have a negative leading coefficient. Between 4 and 36, 4 goes into 36, right? So we're going to pull out negative 4. And amongst the variables, we have y cubed and y. So I can pull a y out. Okay, negative 4y times y squared is negative 4y cubed, right? Negative 4y times negative 9 gives positive 36y, right? Okay, so now I notice something. Upon factoring out that GCF of negative 4y, I'm left with y squared minus 9. Y squared minus 9 is the difference of squares, right? So with the difference of squares, and in this case our a would be y and our b would be 3, right? So 3 squared is 9. Okay, so we're going to have y plus 3 times the quantity y minus 3. Okay, so once you factor a GCF out, always look to see if there's more to do. And in checking this, negative 4y times the quantity y plus 3 times the quantity y minus 3. Leave the GCF alone and do the FOILing. So y plus 3 times y minus 3 is y squared minus 3y plus 3y. 3 times negative 3 is negative 9, right? Okay, and so then we have negative 4y times y squared minus 9, right? We're seeing the work that we did in reverse here. And we're going to distribute the negative 4y through. So negative 4y times y squared is negative 4y cubed, right? And negative 4y times negative 9 is positive 36y. And this is what we started with. So we're in good shape there.